All right, so let's look at 3.6, day 2. And when we're looking at day 2, the problems that we're doing are 9, 23, 33, 41, and 45. Eleanor's not with us today, so we'll be a little quieter. So when we look at 9, if g of x is equal to the natural log of, and inside of that natural log is xe to the negative 2x, what we have to realize is that the form of this thing, if you ask me to take the derivative of this thing, the form is going to be the natural log of stuff. So its derivative is going to be 1 over stuff times the derivative of that stuff. So its derivative is going to be 1 over xe to the negative 2x times the derivative of xe to the negative 2x. Move that over, all this over, xe to the negative 2x. Right? Put that there like that. Boop, boop. Make sure that's an x. So then now I have another derivative to do, and I look at this guy, and I say that the form of this thing is stuff times stuff, so it's going to be the product rule. So we're going to have 1 over xe to the negative 2x times first derivative of second. Why do I keep on jamming that together? X and then derivative of e to the negative 2x. First derivative second plus second derivative of the first. Notice how I had to put that in parentheses. So we're going to get this thing, and then I say that the form of this new derivative is e to the stuff. So its derivative is going to be e to the stuff times the derivative of stuff, and I'm just going to put a negative 2 because that's a derivative. I don't think I have to show that step. So that's what I get, and this is e to the negative 2x times 1 because the derivative of x is 1. So I think you should now see what you really have is in the denominator, you have xe to the negative 2x, and all of this is on top. And you'll notice what is look at 9, what is in both of these terms, because when I look at that, it is a term plus a term. So what is common to both those terms? I can pull out an e to the negative 2x on top. What you're going to be left with is negative 2x plus 1. Right? And so then I guess you can tell that this and this cancel out. And so what you're left with is 1 minus 2x over x. And another way to write that is 1 over x minus 2. So if I just say take the derivative but don't simplify, you would be able to stop here, but I think you can get all the way down to here. It's not too bad. All right, so there's 9. Let's look at 23. So when I look at 23, scroll down to what number 23 is. That is y is equal to the square root of x times the natural log of x. So first thing I'm going to do is rewrite that as x to the 1/2 times ln x. So when you ask me to take the derivative, I want to say that its form is stuff times stuff. So the derivative of that thing is going to be first times the derivative of the second plus the second times the derivative of the first. So that means derivative of ln x is 1 over x, and the derivative of x to the 1/2 is 1/2 x to the negative 1/2, right? So it's 23. And so I'm going to get, let's see. So what we really have is what? 1 over x to the 1/2 plus, and over here we get, let's see, so this should be 1 over x to the 1/2. Is that right? Yeah, 1 over x to the 1/2. And then plus the natural log of x over 2x to the 1/2. Why do they have 4? Why did you have 4? So what I'm going to do is, oh, they wanted a 2 over. I don't know why you would do that. So let me see what I end up getting. So what I'm going to end up getting is, oh, they add and subtract. That's really interesting. Oh, yeah, I haven't done it yet. Sorry, my brain farted. So if I hit this with a 2 and a 2 on top and bottom, I'm making sure to follow along so that I don't have to do this twice. I'm just doing the video on the key at the same time. Sorry, I wasn't looking. And so you get 2 plus the natural log of x over 2x to the 1/2. So that's my first derivative. So if I take the derivative of the first derivative, it just means that you literally take this function and take its derivative. Oh, my nose itches. So I take this thing and I'm going to take its derivative, which should be pretty clear. The form of this thing is quotient, stuff over stuff. So I'm going to get low d high minus high d low. I need to move this over. Low d high minus high d low over low gets squared. So it's going to be low high minus high low all over low gets squared. Okay, so it should be clear that if you square the bottom, you're going to get 4x. Then on top, this derivative right here ends up being 1 over x. So it's going to be 1 over x times 2x to the 1/2. It's going to be minus, and this is going to be 2 plus natural log of x times this derivative right here is going to be 2 times 1/2 of an x to the negative 1/2. So that should just end up being 1 over x to the 1/2. Yep. And so what that's going to give you is 2 over x to the 1/2 minus 2 minus natural log of x over x to the 1/2. All that stuff over 4. No. So, no, that was a bad move. Sorry. Let me be careful. So what I'm going to do before I do anything, let me make it easier for you. Do you see that inside of this term, because this is one big term and this is one big term, do you see that, actually, let me do this. When I write it like this, I can now see that I have 2 over x to the 1/2 minus, and this ends up being 2 plus natural log of x, 1 over x to the 1/2. Well, do you see that in both terms, I have a 1 over x to the 1/2? So I think I could put that x to the 1/2 in the bottom, or let me just factor it out if that makes you happier. So I factor it out. What you have left is 2 minus 2 plus ln x, right? What I have left is 2 minus 2 plus ln x, parenthesis. And so if I give myself a little bit more room, I'm just going to resize all this. Just 1 second. A little bit of room is going to go a long way. So now we've gotten all the way down to here. And do you agree that this x to the 1/2 right here can go on the bottom? So we have 4x times the square root of x, because 1/2 is square root of x. So maybe I write it like this. And then if I distribute this negative to both, I really have 2 minus ln x. So right here, I just have a minus ln x. And that's what your derivative turns out to be, your second derivative. Cool. So that is 23. Now I need to do 33. Let me see, what is 33? So 33 is y is equal to the natural log of x squared minus 3x plus 1. And I want to find the equation of the tangent line at what, comma what? At 33, sorry. So this one is this. I want to find it at 3, 0. 3, comma 0. So I know when I start to answer it that y minus y1 is equal to m x minus x1. This is my x1, y1. So I have y minus 0 is equal to m x minus 3, correct? So then I now need to find m. And to find m, I need the derivative plug in x1. So the derivative at x1. But my derivative is just equal to the derivative of natural log of x squared minus 3x plus 1. And so the form of this thing is natural log of stuff. So its derivative is going to be 1 over stuff times the derivative of that inside stuff. So it's going to end up being 2x minus 3 over x squared minus 3x plus 1 is my derivative. So my slope is the derivative plug in x1, but x1 is 3. Plug in x1, but that's the derivative plug in 3. So if I take this, and everywhere where there's an opening, I plug in a 3, then it turns out that that thing, you take the derivative, evaluate at 3, you end up getting 3. So y minus y1 is equal to m, this m goes right here, m x minus x1 is 3. So you end up getting that y is equal to 3x minus 9. Oh, yes, make sure I got that right. Okay, so there's 33. After 33, we need to do 41 and 45. So let's look at 41. Still doing pretty okay on time. So for 41, oh, this one's amazing. So we get y is equal to the square root of this over this. And it wants us to use logarithmic differentiation. Well, the first thing I notice is it's really just all of this stuff raised to the 1/2. So why does logarithmic differentiation make sense here? Well, I can take the log of both sides, and what that allows me to do is then I can use any of my log rules. So I know that the log of a product is the sum of the logs. I know that the log of a quotient is the difference of the logs. And I know that the log of anything to a power, I can pull that power out front, and I really end up getting, pull it out front, I get power natural log of a. Yeah. So in this case, I have x plus 1 over x to the 4th plus 1. All that to 1/2. I can end up pulling that 1/2 up front. So we get 1/2 natural log of something divided by something. Notice I'm still doing algebra at this point. So this is taking the log so that I can then do logarithmic differentiation. So now notice that this is 1/2 times whatever this is. Well, this stuff in here, I'm going to expand. When I look at it, I see a quotient. I see it as the log of something divided by something else. So what I can do is the natural log of something minus the natural log of something else. So it's going to end up being the natural log of x plus 1 minus the natural log of x to the 4th plus 1. So when I distribute through that 1/2, I get 1/2 ln of x plus 1 minus 1/2 ln of x to the 4th plus 1. So now all that work was to do logarithmic work, and now I'm going to take the derivative and do my differentiation. So if I end up taking the derivative, I take the derivative on the left, I get y prime over y. That's what we get every time when we do this. Because remember, the derivative of natural log of y is 1 over y times the derivative of inside, which is y prime. That's why we always get this. But then I take the derivative of this, I can pull out the constant 1/2. The derivative of ln is 1 over, looks like a z, is 1 over the stuff on the inside times the derivative of that stuff on the inside. Again, it's minus 1/2 for the constant, 1 over the inside times the derivative of the inside. Make sure that we see dots here because it's multiplying. So what we get is that y prime over y is equal to 1 over 2 multiplied by x plus 1 minus 4x cubed over 2 times x to the 4th plus 1. But then to get rid of that y in the bottom, I multiply both sides by y and get this. And then what I can do is I can take all of this and I can resize it. Give myself just a little bit more room. If you have that ability, I would recommend it. So what did we say y was in the very beginning? Well, y was just all this stuff. So that means I can come down here and just replace the y with what it's equal to. So that means that y prime is this stuff times this stuff. Copy and paste. Yep, so that's what it is. So there's your derivative. Which one was that? 41. This, oh, was that a minus 2x? Was that x minus 1? Okay, sorry. Yeah, just go back here. It was x minus 1, so I just made a small boo-boo. So just go back and make that a minus, make that a minus. It doesn't change anything. Make that a minus, and this was green and green. Make this a minus, and this was green, just so you could see it. This is a minus, that's a minus. This is a minus, that's a minus. And this is a minus. So there you go. That's just your answer. Cool. All right, that's 41, the last question. Then I get to go home. It's 45. So let's look at 45. There are people running in the halls like crazy people doing their track inside. Good for them, staying warm. Let's look at 45. It says that y is equal to x to the sine of x. So notice the last question we did, we did not have to do log differentiation. We could have done the chain rule and then the quotient rule, and it would have been super ugly. So we first changed the form using log, and then we took our derivative. So that just made it easier. But if you want to do chain rule and quotients, oh, feel free to. Here, we must use log differentiation because we have a function raised to a function. So we have function 1 raised to function 2. Some function raised to another is what we have. So I first start off by taking the natural log of both sides. Over here it's y, over here it's x to the sine of x. What that allows me to do is pull this exponent down. So we get sine natural log. Over here we have natural log of y. So all I've done so far is take the log, and now what I'm going to do is differentiate. So if I differentiate on the left, I get y prime over y. And over here, the form of this thing is stuff times stuff. So I take the first times the derivative of the second plus the second times the derivative of the first. First or second? Second. First. Well, the derivative of sine is 1 over x. The derivative of natural log is 1 over x. Sine is cosine. And so we end up getting sine over x, sine x over x, plus ln cosine. And then if I multiply both sides by y, I get this. And if I were to leave it like this, it would appear as though y is actually a function, y prime, excuse me, is a function of x's and y's, but it's not, because I can just rewrite my y in terms of what it was in the very beginning. In the very beginning, it was x sine x. So this replaces this, and my derivative becomes x sine x, x to the sine x. Sine x over x plus ln x cosine x. And there you go. Awesome. Have a great one.